Micrometeoroids, space tiny assassins. So you're floating in your billion-dollar spacecraft, admiring the Earth from above, maybe sipping some old recycled space juice that tastes suspiciously like old socks. Everything's calm, peaceful, until bam! A grain of sand-sized psychopath traveling 60 times faster than a bullet slams into your ship. That is what you'd call a micrometeoroid. These tiny cosmic punks are smaller than a breadcrumb, but travel faster than a breakup text. They are born from cosmic trauma, asteroid breakups, comet meltdowns, and other galactic soap opera disasters. Every chip, crack, and crater in the solar system has probably donated a few of these tiny jerks to the mix. Every time the solar system sneezes, one of these particles shows up to make it someone else's problem. Micrometeoroids are basically the space version of dandruff, if dandruff could kill you. They're everywhere, and they're impossible to avoid. Despite being only a few molecules to a tenth of a millimeter wide, micrometeoroids don't play around. They travel at speeds of up to 20 kilometers per second. This is like circling the Earth in just 30 minutes. If they happen to survive the fiery descent through our atmosphere and actually land on Earth, they graduate to a cooler title, micrometeorites. It's like being upgraded from unpaid intern to full-time employee, but instead of benefits, they get to sit in a museum case and confuse geologists. But in space, these things are a nightmare for engineers. A single micrometeoroid could punch holes in spacecraft, scrape off coatings, and slowly eat away at satellites like tiny sandblasters from hell, ruining your billion-dollar ride. That's why spacecraft don't just go to space, they suit up for war. Layers of insulation blankets are wrapped around every inch just to keep these microscopic maniacs from poking holes in your ride. And even then, sometimes they still get in. Because in space, even the dust wants you dead. Lunar dust. So imagine landing on the moon, planting your flag, doing a little astronaut victory hop, and then realizing that everything around you is coated in what feels like angry glitter made of knives. That's lunar dust. Space's answer to what if sand, but worse? At first glance, it just looks like regular dirt, but lunar dust isn't soft, beachy powder. It's made of tiny, jagged shards of crushed rock, basically ground up volcano glass with the personality of a cheese grater. And thanks to the moon's complete lack of weather, none of it's been smoothed out. It's all sharp edges and bad vibes. If you breathe it in, ho ho ho, your lungs are in for a rough time. Apollo astronauts reported coughing, sneezing, and throat irritation just after a short exposure. Think of it as asbestos with commitment issues. Scratchy, clingy, and impossible to ignore. It stops your wound from healing, your lungs from working, and your brain from braining. Because apparently space dust doesn't know when to quit. It also loves getting in your eyes and skin, causing irritation, rashes, and just general "why am I itchy in space" energy. Oh, if you get a cut? Congrats! You're now experimenting with how well open wounds heal when sprinkled with microscopic glass powder. And it doesn't stop with you. It attacks your spacesuit too. It scratches visors, chews through seals, and clings to everything like it paid rent. It sticks to your boots, follows you back into the lunar module, and sets up camp in your air filters like it's part of the crew. Thanks to the moon's low gravity, this stuff doesn't just fall to the ground, it floats in the air like passive-aggressive glitter, waiting for the chance to get in your lungs or short out your gear. Oh, and just to really drive it home, some versions of lunar dust have been shown to trigger reactive oxygen species in the body. Translation: it kicks off cell damage from the inside like it's auditioning for a slow burn horror movie. Black holes. A black hole is space's ultimate ghost trap, a region where gravity gets so intense, it doesn't just pull things in, it erases them. Light can't escape, time gets warped, and the laws of physics basically curl up in the corner and cry. It all starts when a massive star runs out of fuel and collapses in on itself, crushing its entire existence into a singularity, a point so dense it makes atoms look roomy. Surrounding it is the event horizon, the cosmic red line. Crossing it is like slipping behind a curtain that never opens again. There are two main types. Stellar black holes, the leftover cores of stars, which are a few suns heavy, and supermassive black holes, galaxy-sized monsters, sitting at the center like cosmic mob bosses. We can't see them directly, but we watch stars dance around invisible centers and gas spiral in like water circling a drain. That's how we know they're there, by the chaos they leave in their wake. And if you ever fell into one, you'd know. You'd get spaghettified, an actual physics term for being stretched thin by gravity like a sock caught in a meat grinder. The pull on your feet would be way stronger than on your head, so you'd unravel, scream, and then stretch into nothing. Time near a black hole doesn't behave either. It slows down. A lot. From the outside, you'd look like you were falling in forever, frozen just above the event horizon. Meanwhile, you're already spaghetti. Quasars. You know that one annoying neighbor, the one who installs industrial-grade floodlights and points them directly into your bedroom window, like you asked to live in a crime scene reenactment? That's a quasar. Except instead of ruining your sleep schedule, it blinds entire galaxies. Quasars are basically what happens when a supermassive black hole gets messy. Normally, black holes are all silent and mysterious, but give one enough food, dust, gas, stars, you name it, and it lights up like a cosmic rave. All that infalling matter heats up and starts vomiting out radiation like it's on fire, and also mad about it. Now this is not a mere bright light. It's more energy than a trillion suns, focused into a single, screaming galaxy core death spotlight. Quasars are so bright that they can outshine the galaxy that hosts them. It's like having a single stadium light make New York City look dim. But they don't just glow, they lash out. Quasars throw out powerful winds, high-speed outflows that blast away gas and dust at a fraction of the speed of light. These outflows are strong enough to disrupt star formations in other galaxies. That's right, quasars are out here murdering future stars just by being loud and extra. Astronomers call this kind of galactic tantrum a quasar tsunami because, of course, they do. It's not enough for a quasar to be scary, it has to sound like it could star in its own disaster movie. They've also been known to zap galaxies, heating up the gas so much that it can't cool down and collapse into stars anymore. It's the cosmic equivalent of turning off someone's life support with a hairdryer. Fortunately, quasars hang out billions of light years away. Too far to fry anything local, but if one ever flared up nearby, there wouldn't be time to panic. There wouldn't even be time to think about panicking. Just a flash, and then planetary vapor stew. Quasars might not be coming, but they are out there. Loud, unstable, star-killing monsters, powered by black holes having the loudest mental breakdown in the universe. How about you prevent the next one by subscribing? Liking the video also buys you a ticket to safety if one comes your way. Solar flares. So you're out in space when suddenly, the sun decides it's had enough of your peaceful little orbit and punches the cosmos in the face. That's a solar flare, a massive high-energy sucker punch made entirely of radiation and spite. These flares happen when the sun has a magnetic breakdown and throws a fit, launching waves of charged particles into space like it's flinging shrapnel at anyone within reach. Not soft, warm sunbeams, we're talking high-speed protons, moving fast enough to rearrange your organs and your weekend plans. Get caught without shielding? You're not just getting a tan, you're signing up for radiation sickness. The kind that comes with nausea, bone marrow damage, internal bleeding, and your immune system resigning without notice. Stick around long enough and you're also looking at a nice bonus package. Increased risk of cancer, degenerative disease, and the existential dread that comes with realizing you're being slow cooked by the star you used to draw in kindergarten. The official protocol? Hide. If a solar flare is inbound, astronauts are trained to crawl into the most shielded corner of the ship and wait it out like the sun is an angry ex throwing furniture. It's not heroic, it's survival. And while spacecraft do have built-in shielding, space protection is basically a game of how little shielding can we get away with without roasting the crew. Which is not ideal when the sun's out here throwing nuclear tantrums. That's why NASA carefully schedules missions around solar activity, because nothing ruins a mission quite like being flash-fried by star vomit at relativistic speeds. Extreme temperatures. Imagine standing in a place where one side of your body is slow roasting and the other is freezing solid, like someone stuck you between an open oven and a walk-in freezer, then locked the door and threw away the thermostat. That's space. Out here, there's no atmosphere to regulate temperature, which means if you're in direct sunlight, your spacecraft or suit can heat up to 248 degrees Fahrenheit, or 120 degrees Celsius, hot enough to cook a pizza and start a fire you couldn't put out. Step into the shadow side, and the temp plummets to minus 148 degrees Fahrenheit or minus 100 degrees Celsius, cold enough to make your bones question their life choices. It's like living inside an oven that won't pick a setting and won't tell you when it's preheated. The only thing keeping you from experiencing both at once is a suit more engineered than most luxury cars. But with all the extra insulation, the suit also traps the heat your body generates. So while you're working, sweating, and trying not to float off into the abyss, your body starts slow roasting from the inside out. And here's the fun part. In microgravity, sweat doesn't drip. It clings to your skin like guilt. So you're basically stewing in your own spacesuit soup. Heat stroke, exhaustion, dehydration, all real threats. Astronauts have to rely on built-in cooling systems to stop themselves from passing out mid-orbit. It's not just wearing a suit and look cool, it's manage your core temperature like your life depends on it. Because it does. Even the spacecraft aren't immune. Electronics get cranky in extreme heat. Batteries start acting up. Materials warp and degrade like they're aging and fast forward. You basically need heat-proof, cold-proof, meltdown-proof everything just to survive a single orbit. And on Earth, sure, heat waves are rough. But space doesn't do rough. It does instant death with 2 temperature settings. So unless you're wrapped in layers of thermal tech and actively managing your internal temp, like a walking science experiment, space will cook you, freeze you, or, if it's feeling generous, both. Gamma ray bursts. So you're floating in space, doing astronaut business, maybe checking readings, maybe thinking about lunch, when suddenly the sky lights up brighter than a billion suns, having a group therapy meltdown. You don't even have time to scream before your atmosphere gets vaporized and your molecules go on an involuntary vacation. Congrats, you just got slammed by a gamma ray burst or a GRB. GRBs are the brightest, deadliest explosions the universe has ever coughed up. Think blink and your vapor levels of energy, blasted out in gamma rays, the most aggressive form of light there is. If black holes had sniper rifles and no patience, this would be the result. They're quick, they're brutal, and they release more energy in a few seconds than the sun will in its entire 10 billion year career. One moment it's peaceful, the next, you're being lit up by radiation that makes nuclear bombs look like a scented candle. And there are 2 types of GRB. Long GRBs, over 2 seconds, happen when a massive star collapses into a black hole and fires off one last murder beam on its way out. Short GRBs, under 2 seconds, are triggered when 2 neutron stars, or a neutron star and a black hole, violently French kiss and explode in a blaze of existential middle fingers. Either way, everything nearby gets deleted. Thankfully, GRBs usually happen in far-off galaxies, like 13 billion light-years away, which is good, because if one ever happened close to Earth, you'd be gone before your brain could finish the sentence, "What the hell is that?" And just when you think the worst is over, there's an afterglow, a cosmic encore of X-rays, visible light, and radio waves pouring out like the end credits to a disaster movie you weren't invited to survive. Oh, and in 2022, we spotted one so insanely powerful it was nicknamed the BOAT. B-O-A-T. Brightest of all time. That's not hype, that's NASA trying not to panic. Dark matter and dark energy. Now here's something to lose sleep over. Everything you've ever seen, planets, stars, people, pizza, that weird blob in your fridge, makes up only 5% of the universe. The rest? We have no idea. That's not poetic, that's the actual scientific consensus. According to space nerds with terrifying degrees, the other 95% is made up of 2 things we can't see, touch, or explain. Dark matter and dark energy, which is a polite way of saying, yeah, we're pretty sure something's out there, but good luck proving it. Let's break it down. Dark matter, which is 26%, is the universe's passive-aggressive ghost. You can't see it, but galaxies wouldn't hold together without it. It's out there, warping gravity, pulling strings, and acting like the shady landlord of the cosmos. It doesn't glow. It doesn't interact with regular matter. It just exists, like background radiation and bad decisions. Then there's dark energy, which is 69%, and it is somehow worse. It's not holding things together, it's shoving them apart. It's the reason the universe is expanding faster and faster, like it's trying to avoid commitment. Scientists think it's some kind of repulsive force that permeates all of space. So basically, it's everywhere and hates everything. What's it made of? No clue. Where did it come from? Who knows? Can it kill you? Possibly, but not before it makes you feel small and confused. So while textbooks are busy explaining atoms and gravity like it's all figured out, just remember 95% of the universe is running on mystery fuel and denial. And you're part of the 5%, the part that thinks it's in charge. Typical NPC energy.